Welcome to this edition of the Virtual Space TV. I'm Amanda Bush, your host. Today, we are going to focus on the most recent Soyuz launch, the Phobos-Grunt Mars probe, SpaceX and gas stations in space. Nice that you dropped by. On Sunday, November 13th, a Russian Soyuz capsule with one American astronaut and two Russian cosmonauts aboard launched successfully on a Soyuz rocket to the International Space Station. This ended a crisis for the ISS program that might have led to the abandonment of the station for at least several months. In August, a Russian Progress spacecraft carrying cargo to the station failed to reach orbit when the upper stage of its Soyuz rocket prematurely shut down. This led to the grounding of Soyuz rockets for both the Progress and Soyuz spacecraft. With the space shuttles now retired, this meant that there were no vehicles available to take crews to the ISS. Meanwhile, the 6 crew members on the station could remain for only a limited time because of restrictions on how long their Soyuz capsules can stay in space. It appeared possible that they might all have to return to Earth before the Soyuz rocket was once again certified safe to fly. Fortunately, the cause of the rocket failure was quickly determined to be a one-time problem with a fuel pump. The Soyuz was soon recertified for flight, and a new Progress cargo vehicle was launched successfully in October. This paved the way for the manned flight on Sunday. The Soviet Union and Russia have attempted 18 missions to Mars. None have been a complete success. 14 were total failures. The last attempt was 15 years ago, when the Mars 96 mission to the Martian moon Phobos failed to get out of Earth orbit. Hope was high that the new mission would have better luck. The plan was for the Phobos-Grunt spacecraft to land on the small moon Phobos and send back a sample of its surface material to Earth. A Chinese orbiter was also piggybacking on the flight. This would be China's first planetary project. Unfortunately, the Mars god struck again. Initially, the launch on November 8th appeared successful. However, the spacecraft's engine failed to fire, and the spacecraft became stuck in low Earth orbit. Repeated attempts to contact the vehicle and try to debug the problem have failed so far. If the engines do not fire, the vehicle will re-enter the atmosphere within a month or two. The Mars curse on Russian missions continues. SpaceX recently reached a significant milestone in the development of its crew launch system. NASA approved a preliminary design review for the abort and propulsion system for the Dragon capsule. The traditional capsule abort system uses a tower structure on top of the spacecraft that has thrusters to pull the capsule away from an exploding rocket booster. If there is no booster problem, the abort system is discarded after the capsule separates from the upper stage. The Dragon instead uses a pusher-style abort system with thrusters built into the sides at the base of the capsule. This is a simpler, more elegant approach that allows both for safe aborts all the way to orbit, and also means that the thrusters can be used for propulsion in space and during landing. SpaceX, in fact, hopes to take advantage of this built-in propulsion system for landing on other planetary bodies besides Earth. The company recently gave a presentation to NASA in which they proposed sending an unmanned Dragon to land on Mars. The Dragon would carry a drill that would penetrate the Martian surface in search of signs of bacterial life. The cost at $500 million would be quite low compared to other Mars landing missions. The Apollo crews went to the moon by riding atop the gigantic Saturn V rockets. The cancellation of these very expensive vehicles ended the moon missions in 1972. It has generally been assumed that manned missions beyond Earth orbit would need another super heavy lift rocket like the Saturn. However, an alternative approach is getting increasing attention. Most of what the Saturn V launched to orbit was fuel to power the Apollo spacecraft to the Moon. If the spacecraft were launched dry, the mass would be far less, and would allow currently available mid-sized rockets to be used. To fuel the spacecraft, they would rendezvous with propellant depots in orbit. These depots would have been filled previously by multiple launches of mid-sized rockets. The use of fuel depots offers several benefits. There would be no need for the tremendously expensive development of a new heavy lift vehicle. The heavy lifter would also fly very seldom, and so would have very high operating costs. Conversely, the increase in launch rate and competition among multiple providers of mid-sized rockets to service the depots would drive down costs for all users of such rockets. The redundancy and flexibility of depots also brings robustness to such missions, which no longer have to depend on the successful launch of a single giant rocket. If a rocket to add fuel to the depot is lost, this will have little impact on the program. Transfer and storage of fuels for space stations have been common for decades. Long-term storage of cryogenic fuels, especially liquid hydrogen, requires some technology development and demonstrations, but this is generally considered nearly in-hand technology by experts in the field. With budgets for space exploration dropping, fuel depots may provide the only option for beyond-Earth orbit exploration. It is likely that NASA's new Space Launch System heavy lift vehicle will eventually be cancelled before it is finished. It is already so expensive, NASA has no money to develop any missions to fly on it. As with cars, planes and ships, it's better to use gas stations than to try to carry all the fuel for your whole trip. We will be back with the next show at the beginning of December. You can find us as usual on www.hobbyspace.com. Thanks for watching.